Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the basic calculator problem. Given a string s representing a valid expression, implement a basic calculator to evaluate it and return the result of the evaluation. That's not where their sentence ended. Return the result of the evaluation. You are not allowed to use any built-in function which evaluates strings as mathematical expressions such as eval. So this video is being recorded for when I'm on holiday, so hopefully I'll be on holiday, hopefully maybe you'll be on holiday too soon, I don't know, whatever. So this one was recorded a while ago. Anyway, so 1 plus 1 has to evaluate to 2, 2 minus 1 is 1 plus 2 is 3, sure enough it evaluates to 3, and then 1 plus 4 plus 5 plus 2 minus 3 plus 6 plus 8. So it looks like we're only dealing, we're only dealing with pluses and minuses here. Plus is not unary. Minus could be unary. So, just trying to think what's the best way to do this. Well, on the one hand, it's fairly easy, in the sense that there are a lot of known algorithms on how to solve this problem. Basically, the trick is going to be tokenize, then use some sort of shunting yard algorithm to, well, you could either use a shunting yard algorithm to get it into reverse Polish notation and then evaluate the reverse Polish notation, or use the shunting yard algorithm to actually just directly evaluate the expression. So, the real quirk with this one is these negative numbers. So basically minus can be a minus or it can be a negative, so it's a little tricky. So when we go to evaluate it, we're going to need to basically check whether this is going to be considered unary or not. There will be no two consecutive operators in the input. So I think that means you can't have 2 plus negative 3 because that would be two consecutive operators. Unclear what that rule means. It also says you're not allowed to use any built-in function which evaluates strings as mathematical expressions, but I assume we can still use, say, int. To turn this into an integer, because otherwise that makes the problem very tedious, but no harder. Right, so basically what we want to do is tokens is self.tokenize s return eval self.evaluate tokens evaluate tokens. So, tokenize self s. Basically, what we need to do is tokes is an empty list. Tok is an empty string. So this is going to be a fairly standard tokenization for car in S. If car is a space and tok does not equal, no, actually, hang on. Let's do this deeply nested first. If the character is a space, basically what we want to do is go toks.append tok. We are done with whatever token we're dealing with. There is no space in the middle of a number or anything like that. But we only want to do that if the token is worth appending, basically. If the character is a plus, whatever we were looking at is now done. If toks.append tok, tok equals empty. So this code is going to come up a lot. Tok equals empty, and tox.append a plus. In fact, we want to do that regardless. So this little bit here is basically our clear this, we're moving on to the next thing. In fact, this is also true for the minus. For the, in fact, if car in, there we go, plus, minus, or parentheses. If it's any of those, we're done with whatever other token we were making. So just push it on. Else toc plus equals car. So if it's not a space, and it's not a plus, and it's not a minus, and it's not an open paren, and it's not a closed paren, then it must be a digit. So we want to build up our token. Then finally, if tox.append toc, return tox. So let's first here print tokens, not brokens, tokens. And just so we don't get too many errors, let's do evaluate self tokens, return 0. So obviously this doesn't work yet. I just want to see what we get. So 1 plus 1 breaks down correctly. Two minus 1 plus 2. That evaluates correctly. This is an open paren, a 1 plus 4 plus 5 plus 2. So these ones are all fairly trivial because they just discarded spaces and return things. So what if I do 42 plus 67? Good, they got grouped into numbers correctly. I think something else I want to do is turn the integers into integers. Yeah, so now the integers are actually integers in our evaluation. One thing I do want to test is negatives. Negative 11 plus 9. So that's doing it like that. And let's also do 32 plus negative 5. Let's see if that counts as valid. Invalid expression. So we can't have something like this. But if I did that, oh no, that's still invalid. But that might be valid. Aha, so that is valid. We can have a 32 plus negative 5 if the negative 5 is in parentheses. Right, so we now have a tokenization running. Now what we need to do is effectively evaluate it in some way. Now, there's an algorithm for this, and I think it's called the shunting yard algorithm. And do you think I remember what it is? I do not remember what it is. So we're going to have to do a little bit of recreation to try and work out how on earth the shunting yard algorithm works. But I do know in general. So let's say our stack is 1 plus 1. What I want to do is... Now, we've only got pluses and minuses, so this is largely trivial. Basically, what I want to do is put the 1 on one stack, so it's nums goes on one stack, and ops goes on the other stack. So for toc in tokens if is instance top int nums.append tok elif tok in plus or minus, oops, ops.append token. Or tok is equal to an opening paren as well. Now that's a bit of a special case because how we handle parentheses is we basically create a new mini stack. And the idea is that elif tok is equal to a closed paren. This is where the magic happens. And there's also some magic happening after we've gone through all of our tokens. So, and it's the same magic basically. So if I've got, let's say I've got four, what? Yeah, I'm just trying to think what's the right way to do this. The idea is, well, if I get all the way to the end, let's do this one as a pass for now. We'll handle parentheses in a minute. And the idea is while ops, op is ops.pop. We want to work backwards down our ops stack. A2 is nums.pop. A1 is nums.pop. And then I want to do a self, then I want to do if op is equal to plus nums.append A1 plus A2, else nums.append A1 minus A2. There's some mess around here with negatives, but for now that'll do. So we should pass the first and second cases. Hang on, I don't want to get rid of these test cases. Let me just put some test cases down here. Cut those, paste them there. Let's try this again. Okay, we're getting it wrong. Oh, that's because I need to... Okay. Yep, that is a problem. I'm evaluating these things right to left, so I've got this algorithm wrong, and I kind of knew I had it wrong. So the 1 plus 1 works. This is wrong, because what we need to do is we need a 2 plus 1. Sorry, a 2 minus 1. We need to push the 2 on. We need to put the 1 on the ops stack. Then we put the 1 on the number stack. Then we want to pop off the ops stack. Or is the easier way to do this just to work forward? because it's 2, 1, minus 2 plus, which is basically where I'm trying to end up. So if you've not seen this before, there's this idea called reverse Polish notation, where if I've got 2 minus 1 plus 2, this is ambiguous. Is it doing this or is it doing this? Now, we know by convention that these two read tighter, just because it's left to right. There's no BEDMAS or PEMDAS or anything like that going on here, apart from parentheses, but that's not relevant for this particular one anyway. But there's this reverse Polish notation, which is used in all calculators, where we can convert this into 2, 1, minus 2 plus. And the idea here is there's now no ambiguity. 2, 1, minus. That is it. That is how you read that. You evaluate that, and then that turns into a 1. So you've got a 1 here, 1, 2 plus. There's no ambiguity on how you read that, so it's a 3. But how do I get into this? And again, I've forgotten the algorithm for this, and I'm trying to be slightly clever and evaluate it at the same moment. So how do I do this? Maybe rather than trying to evaluate it, let's just go into straight into reverse Polish notation. So if I've got 2 minus 1, that's going to be 2, hold the minus, 1, push the minus. So not nums, but out. And we'll deal with parentheses later. So this I want to do out.append toc, ops.pop, ops.append toc. And then for now, let's just print out. Return 0. The nice thing is, if we're going to this reverse Polish notation, pop from empty list. Oh. Oops. While ops out.append ops.pop. So now we've got 1, 1 plus, and now we've got 2, 1 minus 2 plus. So that's exactly what we expected to see. I kind of want to handle this one now as well. Because this will fail. Oh, it didn't fail. That got me an 11 minus 9 plus. So that's actually what we want. That's good. Because then if we try to apply this negative, it's fine, because if we can't pop enough, then we just assume it's a unary minus, that it's a negation. Good. Now we need to handle parentheses. And the way they work is basically this while ops.pop business is very much what we want to do. So if I see this open parentheses 1, so I need to store this somehow. Let's work out what we're going to. I need to turn this into a 1, a 4, 5 plus 2 plus 3 minus 6, 8 plus. So the idea here was the 1 needs to be added to something, which is actually this chunk here, because that's what's in the parentheses. So I move the 1 to the output, and I'm going to, I think what I need to do is I need to put this parenthesis onto the ops stack, and when I see a close parenthesis, clear the ops stack down to the open parenthesis. So if we consider that with our two stacks, out is that and ops is this. So ops gets an open paren on it without a closed paren. This gets a 1. This gets a plus. This gets an open paren. This gets a 4. This gets a plus. This gets a 5. And then we see a plus, so we need to move that plus over and then push the plus on. We see a 2, and then we see a closed parenthesis. So we're going to move everything from this stack down to the next open parenthesis across. That's good. We see a 3. Ooh, that's not good. No, we saw a minus, sorry. So we then move the plus over. Then we see a closed parenthesis, which means we move the, sorry, we saw a 3, then we saw a closed parenthesis, which means we move the minus over and clear all the way down to the open parenthesis. Okay. If ops and ops -1 does not equal an open parenthesis. I think that's a trick we need to do here. And then it's elif toc is the open parent. Oops. For some reason that kills my undo. Elif toc is equal to open parenthesis. So I have Control D bound on my keyboard to be, in theory, forward delete one character, but Leetcode rebinds that to be delete whole line, which is really not what I want to do. Ops.append toc. Elif toc is equal to the close paren, while ops -1 does not equal the open paren, out.append ops.pop, ops.pop, because we want to get rid of that open paren there. So, oops, let's think about this. Going back to this example here, can I get this all on screen? Can I hide this so I can make it slightly smaller? So let's start with our empty stacks. So I see an open paren. That means I want to put it there. I see a 1 that immediately goes on the out. I see a plus. So I want to leave that leave that there because the top is an open paren. So I'm just going to put the plus straight on here. I see another open paren. So I put that on. I see a 4, so that goes on my numbers. I see a plus, so that goes on here. I see a 5, so that goes on my numbers. I see a plus, so I take the plus off there, move it over here, and put the plus on here. I see a 2, so that goes over here. I see a closed paren, so that means I'm going to move the plus over. And then I've reached my open bracket, so I'm going to remove that. I see a minus, so I'm over here. I'm going to move the plus over and push the minus onto the op stack. I see a closed paren, so I'm going to move. Sorry, no, I don't. I see a 3, so I'm going to move the 3 over. No, push the 3 straight onto the out. Then I see the closed paren, so that means I'm going to move the minus over and clear this open paren. I see a plus. I see an open paren. I see a 6. I see a plus, which goes after an open paren, so I don't do any popping. I see an 8, so that goes on. I see a closed paren, so I'm going to move the plus over and delete that. My loop is now done. So if there's any operators, they need to get moved over. So now I'm left with 1, 4, 5 plus 2 plus 3 minus 6, 8 plus. So this isn't so much evaluate as parse, I guess. The RPN is self.parse the tokens, and then I want to do return self.evaluate of the RPN. So let's also print the RPN. So here I want to return out. Whew. Let's put this example back in because I want it, and I also want this one, because these should now all parse correctly, and def evaluate self RPN, and this is going to return 0 for now. Let's see what this does. We've got lots of output, which is good. So the 1 plus 1 turned into a 1, 1 plus. That looks good. A 2 minus 1 plus 2 turned into 2, 1 minus 2 plus, which is good. Negative 11 plus 9 turned into an 11. Negate 9 plus. This monstrosity turned into a 1, 4, 5 plus 2, 2 plus plus 3 minus 6, 8 plus plus. Excellent. That's what we expected. This 32 plus negative 5. Ooh, that's going to be a problem. That's going to break things horribly. That's going to do a 32 minus 5, which is kind of correct, but then leave me with a plus hanging around, which doesn't do anything. Maybe that's okay. I'm just thinking, if we run out of arguments for both of these, there's an easy fix, because if you're doing a negation operation, that's 0 minus the op, 0 minus the number. And if you're doing an addition but you're missing something, you can just do 0 plus that number. So if you can't pop, you just want to minus. Right. So the stack is RPN reversed, and I'm making a slice so that I'm not going to destroy my reverse Polish notation. And I want it reversed just so I can pop and push easier. So what I want to do is while len stack is greater than 1, arg1 is equal to stack dot pop, arg2 is equal to stack dot pop if arg2 in plus or minus op is equal to arg2, arg2 is equal to arg1, arg1 is equal to 0, else op is equal to stack pop. There we go, I can finally spell the word pop. Who would have thought that would be a tricky one? So this handles our weirdness here. So we've got the 32, we've got the 5, we've got the minus. And then once we've assumed we've reverted those down to a 27, we're going to do 27 plus. This arg2 is going to be a plus. So this is where we're going to turn arg1 into a 0. Arg2 is arg1 and op is what arg2 was. So then it's if op is equal to plus stack dot push arg1 plus arg2 else stack dot push arg1 minus arg2, because our only options are plus or minus. We don't really need to check that the other one is a minus. And then just return stack 0. Type error in string requires string as left operand, not int. Oh. So we can't do if5 in this thing. So the better check might be if is instance arg2 string. Sorry. So if it's a string, then we know it's a plus or a minus anyway. List object has no attribute push. Whoops. And because I'm thinking in stacks, but in Python we call a push an append. That's all right. Wrong answer. 2, 3, -2, -10, 27. You know what I want to do? I want to print what we're doing. arg1 op arg2 stack -1. Show me at every step what is going on. One, 4. Oh. Oh, bloody hell, I've got this algorithm wrong again. That's not how you do this. Nums is equal to the empty stack. While stack. So what I want to do is actually completely different to this. I have this completely wrong in my head, and I have no idea how I got it so far wrong. What I want to do is if is instance stack -1 int nums.append stack.pop else elif stack -1 is equal to a plus. Actually, no, let's do this slightly differently. Else op is stack.pop. If op equals plus, arg2 is nums.pop, arg1 is nums.pop, stack.push, arg1 plus arg2. In fact, this is true no matter what op we're doing. So that can actually live there. This editor is terrible. Else stack.append, not push. So let's get rid of all that. arg1 op arg2, not stack, it's nums. Let's try that. I'm slowly rediscovering all of these. Pop from an empty list. Except index error arg1 is equal to 0. Okay, that works. I am a bit worried. Oops, that's not the one I want to check. That something like that will break. No, not broken yet. So, the reason I'm a bit concerned is that it's not clear to me whether the question is designed in such a way that the negation doesn't need to be specially handled, or whether I haven't found the test case where it does need to be specially handled. Perhaps it doesn't need to be specially handled. Perhaps this kind of thing is absolutely fine. Where would it go wrong? It would go wrong if my stack basically I want to have two things on the stack with a negative hiding there where it shouldn't be hiding. Maybe this doesn't need special handling. You know what? I can't actually think of how to even craft a case where this wouldn't work, which is good. It seems promising. Let's submit and see what happens. Wrong answer. That's the case I hadn't worked out. 1 minus minus 2. Oops, I've got a blank line on that input. Yeah. Okay, the question is, do I want to handle this at tokenization or at parsing? I think I want to handle this at tokenization. So a minus can only occur either at the beginning of a negation can only occur at either the beginning of the string or immediately after a parenthesis. So if car is equal to minus, so this is where we handle unary negation. If tox -1, so if there are no tokens at all, if not tox, and not tok, so not only have we not seen anything, but there's also nothing ready to move, or tox -1 is equal to an opening parenthesis and there's nothing ready to move. These are the situations where what we actually want to do is if tok, actually tok plus equals car, I think is what we want to do. So I was about to produce a new operator, have like a tilde or something for a unary negation, but we could actually just let the tokenizer turn it into an int correctly. Need to check before I peek. Ah. So here, when we do this, we need to make sure it's not just that minus we immediately put on. Wrong answer still. We output a -3 when we should have output a 3. Oh, actually, that means we shouldn't have to do this anymore. So this is all... Oops, wrong. Oh, I know what's going on. We're still outputting a negation. So actually, we just need to handle this entirely separately. All of that gets indented. This gets done there. Yeah, that should handle more. Oh, I'm not signed in. Well, I know that's not correct. It times out or something. I don't quite know what it is. Oh, I've lost all my test cases. 1 minus -2. Two 23 1 1. What? No, what? That's wildly wrong. Oh, it's this case. So the 2 is in talk. Both of these require that there be nothing in toke, so that makes no sense to be put there. Uh-oh. I need to redo this logic if I see a negation that doesn't. No, I can handle this better. I can handle this better. And almost used the wrong key combo again. All of that mess. I don't like how that broke. Let's do it there. That's better. No, I don't like that either. No, I do like that better. No, I do like that better. Let's try that. Sorry, I'm struggling. There we go. That's better. The other way to handle this would be here. Let's submit this, see if this works at all before I go down that road. Okay, no, we're much better off handling this differently. Ops.append. No, tox.append. Neg. That's what it is. Let's not do any of this weirdness with putting a minus and letting this all handle it. It's breaking things, basically. So let's do this. We now have a neg. In fact, no, just to make my life easier, I'm going to make it a tilde. We want to handle that there. In the parse case. So here now we don't want this. What we want to do is if op is equal to tilde, we'll do some special casing, else this is where we're going to get our other things. So if we see an op, what we want to do is we want to do a nums.append negative arg2. Let's steal this test case. Excellent, it works. The reason I chose this character is because it's using standard ML to use unary negation, because it can't handle the case that I'm struggling to handle. So basically we need to detect it here when we're parsing, tokenizing, so that we're emitting the right kind of token, because a minus is not a negation. They look the same, but they are different. The other place we could try and handle it is in parse, but that's probably a bit more sophisticated, and I don't want to have to try and code that up. So let's submit. This feels better. Yes, there we go. Excellent. So this one is a hard problem, more just because it's a big problem. And the unary negation. The unary negation is the wrinkle up here. But the actual pieces are quite standard. Tokenize, parse, and evaluate. So I was trying initially to merge parse and evaluate. And that probably worked fine if we didn't have unary negation to deal with. Because once you've got it here, it's quite straightforward. Once you've got it here, it's quite straightforward to probably blend it with this. But anyway, it is what it is. Right. That is it. Do let me know how you got on with this one. This one is hard, and there's probably lots of different ways to handle this. So I turned this into reverse Polish notation. Another probably very good strategy would be to turn this into some sort of tree that you could then walk to evaluate. So that would be much more in line with a typical programming language. This one's a little bit Forth-y. If you've ever played with Forth, if you haven't played with Forth, go play with Forth. It's a very cool language, or family of languages. This reverse Polish notation, which I don't have an example of anymore, is kind of a reverse Lisp. If you've seen Lisp, that's all about prefix notation. So you'll have +1, 2 to say 1 + 2. Lots to explore coming off of this problem, so definitely worth broadening your horizons. But anyway, that's it from me for today. I don't know when I'll be back because, again, I'm recording this miles early. I don't know when this will be played. But do stay safe, have a good holiday if you're on holiday as well, and if you're not, hopefully your holidays aren't too far away. Do remember to like, comment, subscribe, all of that good stuff. Don't let the algorithm forget I exist, and I will see you next time. Bye.